Okay, so I want to start with my usual customary update on the two rovers that are still operating on Mars. So today is the 4,624th day for Opportunity, and yesterday was actually its 13th anniversary on Mars. And how many of you were with us on January 24th of 2004 for the landing event? Okay, a few of you. So just quickly, I want to show a birthday video for Opportunity.
Opportunity's turning 13.
13, wow.
The teenage years.
Opportunity has turned into quite the mountain climber.
But sometimes she's too optimistic and thinks she can keep driving when she really shouldn't. Like a typical teenager, she tends to think she's invincible.
Sometimes she stays up really late talking to her friends, Odyssey and Nate and the Mars orbiters. She even pulls all-nighters sometimes, looking at the moon, Phobos or Deimos.
Opportunity loves to document everything. She just loves to share pictures.
Sometimes she gives us a silent treatment.
It's not that she doesn't want to call home.
We know Opportunity's been up to something because there's less energy in the batteries than there was when she called home.
Sometimes Opportunity thinks she's smarter than us and refuses to go where we tell her to go.
She's usually right. She roved her first marathon last year farther than any other rover in history.
She's received a number of software updates. She's become smarter. She's definitely maturing as she's growing up.
Opportunities taught us that the water on Mars would have been something that life could have lived in.
Congratulations on becoming a teenager, Opportunity. Here's to at least another 13 years of exploring Mars.
Happy 13th birthday.
Happy birthday, Opportunity. Remember the day you landed like it was yesterday.
Happy 13th birthday, Oppie.
And many more.
Okay, so that's the big success story. So this is just the statistics for both Spirit and Opportunity. Spirit landed on January 4th of 2004, so roughly 3 weeks earlier than Opportunity. It survived for 6 years. Just to remind you on these statistics, the two rovers were designed for 90-day missions. We would count it as a success if they returned 1,000 images, and if they traveled 1 kilometer, which would be 0.6 miles. And so Opportunity is obviously the more productive of the two, just because it has survived for this long. So what is it that led to the extended life? First of all, it's a really great design, very robust. But one of the things that went into the idea of a 90-day mission was the previous mission, Pathfinder, in 1997, had an experiment with a little solar cell on it. And they could measure, as the dust from the atmosphere settled out on the solar cell, how much light was blocked out. And it ended up being about 0.5% a day that they were losing on the solar panels. And the two rovers are solar powered. These are the solar panels. And so they expected after about 90 days, they wouldn't have enough electricity being generated to continue operating. And so this is sort of a self-portrait using the camera on the mast of the rover looking down. And you can see how dirty the the solar panels are, but lo and behold, there's lots of dust devils at both of the landing sites. And every now and then a dust devil would blow the dust off, and it would become a shiny, clean rover again. And that has happened over and over and over again. So that's how we got to the 13-year point. So here's where we are right now. Opportunity landed up here. It's driven about 40 odd kilometers. This is a 20-kilometer diameter impact crater, and it's roving along on the rim of the crater. This is a closer up view from orbit. You can maybe see the squiggly line here. So this is the rim of the crater. This is the interior, and a closer up view. This is what they've been doing for the last multiple years, and here's where they are right now. And the expectation is that they're going to continue on here and then head south about 1 kilometer for this gully that appears to have been carved by running water. And they mentioned in the video that in the last month, Opportunity stayed up late, and it took images of one of the 2 Martian moons. This is Deimos. It's about 20,000 kilometers from Mars, so much closer than Earth's moon is. It only takes about 30 hours to make one complete orbit of Mars. And it's about 8 kilometers or so in the long dimension. It's very irregular. So that's what it looked like from Opportunity. Just a bright star. And so here's where they are right now. So they're still using the robotic arm. It's got a microscope camera. It's got a grinding tool and a couple of spectrometers. One of the 2 spectrometers has died. The other one, they can still get some information on the composition of the surface. And this is looking at the road ahead. So they're driving in this direction. They need to get up over this ridge and multiple more ridges to make their way down to that gully. And so here's the recap for Opportunity. 43.8 kilometers and a little over 216,000 images so far. So happy birthday. So on the opposite side of Mars, we have the Curiosity rover, which has been on Mars for, let's see, it landed in 2012. So we're it'll be 5 years in August when it landed. And we're at day 1590 today. And Opportunity landed in this 100-kilometer diameter crater. Here's where it set down. And it's at the base of this large mountain called Mount Sharp. It's about 5 kilometers tall. And this is what Mount Sharp looked like after landing. So it's layered rocks. And what they're attempting to do is slowly make their way up the foothills and take measurements of the composition of the rocks, determine what the environment was like when the rocks were laid down, and see how that changed with time. The older rocks are lower, the higher you get, the younger the rocks are. And so this is a view from orbit where they landed. There's a series of fairly thick sand dunes here. The mountain, Mount Sharp, is down here. So they skirted these sand dunes until they got to an area where they could cross the dunes. And right now they're sitting about right here. And this is the plan for the coming year. And I think next we have just a higher resolution view of where they're actually sitting right now. The dark stuff is the sand, so they're working their way through this gap. And this is just a cartoon sort of showing the topography and the different geologic formations that they're on. So they've collected samples along the way, and now they're starting the climb up the slope. And just in case you think this is really steep, this is exaggerated by a factor of 14 in the vertical dimension. So they've climbed about 400 or 300 meters so far in elevation. And this is just looking in the direction that they're traveling. So this is their near-term goal, is to get into this area where there's lots of hematite, which indicates that the rocks were underwater with dissolved iron minerals in them. And then with time, they want to climb up this fairly steep slope. And this is, in the last month, they've been examining some rocks at their feet. And this is pretty good evidence that there was water here, and they know that from the chemistry as well. But this is mudstone, and it looks very much like what you'd see if a lake dries up and it's got muddy stuff in the bottom of it. When that dries up, you tend to get these sort of polygonal fractures, and it's sort of dried mud that ultimately ends up getting converted into rock. And what they're really interested in is you get these cracks in the rock, and they tend to fill with this bright stuff, and that's gypsum, just like drywall. And gypsum is a calcium sulfate mineral, and it's very easily dissolved in water, and so this indicates that there was groundwater percolating through these cracks, and then the gypsum precipitates. But the one interesting chemical result is when they've sampled the veins of gypsum, they're also seeing an enhanced amount of boron. And that's the first time on Mars that they've seen that. And boron is one of these materials that's very soluble in water. And so there's a couple of models for how that might work. One is that you've got boron just already in the rocks, and then you crack the rocks, and then you have groundwater percolating up through the fractures. It dissolves the boron in the wet rocks, and it migrates to the veins, and then what you're left with is the gypsum with all the boron enhanced. The other possibility is this was a lake bed, and you've got water on the top. Boron is dissolved in the water. The water evaporates. It leaves behind what's called an evaporite, which is all the dissolved stuff. The salts get left behind. It forms a layer at the top, and then you have the groundwater comes through. This stuff gets wet, and the boron dissolves, and it sort of percolates down into the cracks, and once again you get the gypsum with the boron enhancing it. So it's just another entry in the water story for this area. Either way, it indicates that there certainly was water sitting on the surface and then subsequently percolating from below through the rocks. One of the major stories in the last month or so has been the drill on board, and this is just views of the 15 drill holes that have been made so far. And the drill is really a very essential instrument on board, because the drill allows you to pulverize the rock. They're able to pick up samples of the powder, put it into their onboard instruments, determine the chemistry of the material as well as the crystalline structure. And so you have to be able to collect those samples to get the detailed chemistry. And what's happened is over the last couple of months, there's been intermittent problems with the drill. So this is a view of, here's the drill bit. And when you're using the drill, there's these probes, and they lower the arm, the robot arm, down to the surface until these probes hit the surface. And then there's a motor that extends the drill bit down to the surface, and it does two things. It rotates, and then it also hammers. And there's been a problem in the mechanism that extends the drill bit. It seems to be an intermittent short where it just stalls. And they've gotten very concerned. They want to be very careful so they don't damage it. And they think that after much diagnostics that there's sort of an intermittent short in the brake on the system. There's an electronic brake on the electric motor, and they think they have a way around that, but for the moment they're prohibiting use of the drill. So it's not going to be used for a while until they can do a lot more testing and determine that they've got a solution that's safe. So I'll keep you posted on that. Just some pretty pictures from the last few days. This is looking down at a very leafy layered rock. It's again, it's probably mudstone. You've eroded material between the stronger layers and left with these very thin exposures of the stronger rock. This is probably about half a meter across, I think, from the distance that they're looking. So it's the whole rock itself is probably about a meter long. It extends up in this direction. And this is just looking in the direction that they're trying to travel. You see lots of these layered mudstones in the way. And this is a view from their navigation camera. So there's Mount Sharp off in the distance, and here's where they're heading. Okay, so there's the recap. Again, they've driven about a third the distance of Opportunity, but of course they've only been on the surface for about a third as long. But they've taken almost twice as many images. So still proceeding well.